Okay, welcome back, everyone. Happy Friday. Before we dig into the main kind of featured stuff for today, I wanted to check in to see how everyone's feeling about NumPy. How are you feeling after yesterday's lecture? And then the other piece is I had included some suggested NumPy exercises at the end of the slides on Wednesday. So if you have had a chance to look at them, do you have any questions or issues that came up, stuff you want to talk about? I wanted to leave a few minutes for that. Yes, Allison.
Yeah, I started going through them, so I definitely have a bunch of questions. I guess I can ask a few and then you can cut me off, or I can always stay after class. So my first question was, do all arrays, like when they print out, do they always have a number and a period after them? Each of the elements, I mean? That was like something I noticed.
Do you want to screen share to show me what you mean, or?
Maybe they're not all like that. I noticed like some of them, when the array prints out, it has the number, then a period, and then the comma, but then sometimes it doesn't have a period after the number.
So let me share my screen.
I was trying to look for an example, but couldn't find one. That's why I didn't.
Yeah. Let me I want to make sure I'm understanding what you're asking. So you're saying, so you import NumPy, and then let's say you make a new array, and then you print it out. Okay, so there's no periods there.
I know sometimes when I did it did, but maybe I just,
if you're dealing, it might be a floating point thing. So if I make this 3.0, it'll turn all of these numbers into floating points. And the period is like shorthand. So one period, if you do type of that, it'll be a float. So it's like a shorthand for 1.0.
Okay.
So,
okay.
Same thing. So that might be.
Yeah, I think that's probably it, then that makes more sense.
Okay.
And then also another question I had was, do you only need to import NumPy once, like at the very beginning, for all the different arrays you're making?
Yeah, if you're importing it at the top of your notebook, and for almost every application in this course, you just have to import things once, and generally the best place to do that is right at the top of the notebook. Okay. There is technically another situation where you wouldn't put an import at the top. So, if you have some function, with your arguments and keyword arguments, if you had some library that you only wanted to import if you called that one function, then you can have an import statement in there. And then, some libraries are expensive to import, like, it'll start using like many gigabytes of memory. And then, you could set things up like that. But in this course, we generally won't think about memory optimization and that sort of thing. So,
okay. Just put it at the beginning then.
Yep.
And then another question I had was, it says like to find, create a 4x7 array of random ints between 6 and 30. Does that include 6 and 30? What is that?
I mean, it's just a practice, but
or like,
the function that, yeah, so if you go to np.random.randint, I think it's called, so we can see what's the int. You have to spell it right. So that'll go from whatever the low value you pass in. Well, actually, it's worth seeing what it does if you just pass in one value. So np. Random dot rand int, and let's say I'm going to have it go. Well, we'll see what this does. Let's say I want, you said 4 by 7.
Yeah, it says create a 4x7 array of random ints between 6 and 30. Really, my question was, does between 6 and 30 mean inclusive of 30?
Yeah, so and to do that, you just say 6 and then high equals, you have to go 31.
Okay, yeah, that's what I
because,
did. Okay.
It's because the upper bound, so the lower bound is inclusive.
Okay.
And then the upper bound is exclusive, which means it's counting from 6 to 1 before 30.
Okay.
So let's see. Yeah, so we got some 30s in there. Well, a single
Okay.
30. Nope, we have another one. There we go.
And then I could figure out how to do the part where you print whether there's a 30 in there, but I was having a hard time figuring out how to print the number of 30s.
Yeah, does anyone have any ideas for that?
I looked up a bunch of different code online, but nothing was working. So
okay. Yeah, it's a good one to figure out. Okay, so here's our array. So we could just manually count. So we've got 130, 2 30s, 3 30s here. So anyone have any ideas how we could count up the number of 30s?
A for loop that adds 1 anytime I equals 30.
Sure. So we could say for I in range x dot shape of 0. So that for the row I, and then for j in range x dot shape of 1, if x of ij is equal to 30, then we could increment count. And we can see what count is. So that works. There's a faster way though. Anyone have another idea?
it seems like there were some functions that were like pre-made into NumPy you could use. I just couldn't figure out how to work them.
So the simplest, yeah, so there's a few that are kind of particularly convenient. So one is you can just say, let's make an array where all the values are false if they're not equal to 30 and true otherwise. So to do that, you can just use the logical test. So now we've got a true wherever there's a 30 and a false everywhere else. So we've got 3 true values, and true is interpreted as a 1 and false is interpreted as 0. So np.sum adds up all the elements of an array, and np.sum of all the places where x is equal to 30 gives you the number of 30s.
So are you saying true is 0 and then 1 is false, or the other way around?
No, true is 1 and false is 0.
So, okay, and because we're looking for the true statements, that works out.
That's right. You could also count up the number of times, this was not equal to 30. Oops. I always forget the syntax there. Different languages have different characters for not, but in Python, apparently it's an exclamation point. There we go. Okay, there's another, there are many ways to solve this. Another is to use something called np.where. So that finds the places where some condition is true. So we could say np.where x is equal to 30. That will return the rows and columns of those positions. So if I say ins of this, so that'll give me those arrays. And then if I say x of ins, it'll give me all the 30s in that array. And then length of this will be the number of 30s.
Is ins just a random name?
Yeah, ins, it's just like indices. Yeah,
Okay, that could
we
be
could have called them elephants.
okay.
And then, oops, that would have been just fine. Yep.
I have a question. Like for the first method we were using, I don't understand the I and the DJ.
This one,
Yes.
you don't understand what's happening there. Yeah, so
Yes.
yeah, so let's dig into the shape. So X has 4 rows and 7 columns. Shape tells you the length of each dimension. So just X dot shape, this is, so if a list looking thing has rounded parentheses, like, or normal parentheses, I don't know, whatever you want to call them, it's called a tuple, which you can think of as the same thing as a list. There's technically a difference, which is that tuples can't be, like, they're kind of read only, whereas lists are writable, but we don't have to care in this instance. But X dot shape of 0 is going to return the like index 0 element of this tuple, which is going to be 4. And then X dot shape of 1 is going to return the 1 index element, which is going to be 7. And then, so for I in range of 4, and then, oops, for J in range of 7, we could print out IJ. Oops. There we go. And see what happens. So first, well, the first time this loop goes through, the row we're dealing with is 0. And then for the row 0, we're going to loop through all of the columns.
Mhm.
And so the indices, or the places it's going to search, are row 0, column 0, row 0, column 1, all the way up through row 0, column 6. Then then that gets us through the inner loop here. And then we're on the second iteration of the outer loop. And now we go for the second row, or row index 1, all of the inner loop columns. And then we do that until we are at the last row, which gets us to the end of the outer loop, and then the last column, which gets us to the end of the inner loop. Does that make sense?
Yes, I think
then-
I know what's going on.
And then we could also print out, like, what's the value of X at, so we could say like X of IJ, and then we could print out what that actually is. And what it's doing is it's just going through these values. So row 0, column 0 is 23. Row 3, column 6, which is the last thing, that's 26, etc. All right. What else?
Should I ask other questions then?
Yeah, if you have other questions, sure.
Okay. All right, so that was helpful. Okay, another question I had was for the fourth one, it says create an array containing the first 10 cubes starting from 1. And it says, I don't know if this is, I think it's this, and then I don't know if this is a separate question or same part of the question. The second part that says create a function that returns an array containing the square roots of n evenly spaced. What does it mean by evenly spaced?
let's do each of those in turn. So how could you create a list of the cubes from, you know, I don't know, we could start with 0 or 10, it doesn't matter. Let's do the cubes from 1 to 10. So we'll cube 1, that'll be the first element, cube 2, that'll be the second element. How could we do that?
I mean, you could hard code it, but if you didn't want to hard code it, I did.
Yeah, no, we don't want to hard code it. Because I could have said 1,000 and then.
Right. Yeah, I did. Called the variable d. I said d equals np.arrange from the numbers like 1 to 10. And then I did d
Okay.
2 stars 3 for like multiple. Yeah.
Okay. Yeah. So, yeah. So.
Or it would be d. Well, you have to multiply the d. You need to cube the second, like for the line when you're calling d, you have to cube it because right now it's just.
Okay. So yeah. So one thing is to go all the way to 10, we have to set the upper limit because the upper limit is exclusive. So we'll have to set the upper limit to 1 more than the thing we want to go to.
Okay.
So that'll get us to 10. And then if we want everything squared, we can just, or sorry, everything cubed, we'll just raise it to the power of 3.
Oh, so you can do it all in one step, basically, is what you're saying.
All in one step. Yep.
Okay.
Yes, Kareem. Oh, you're muted.
What if we made the range from 0 to 10? Would that work too? Yeah.
So like np.a range 0, 10.
Yeah.
Yeah, so that'll have 10 things and we could cube them.
Okay.
Um,
Would it be the same 10 that you'd get if you made it from range 1 to 11, or is it dependent on the indices?
no, it's going to be like shifted by 1, right? So,
Okay.
yeah, so do you include 0 and do you include 10?
Mhm.
Yeah, so the syntax is where do you start inclusive and where do you end exclusive? There's another way to do this also, which is to use the power function. So np.power takes in, you know, an array and the power you want to raise it to. So if my array is the integers 1 through 10, and I want to raise that to the 3rd power, then I can use the power function to do that. Just, you know, there are tons of ways to solve each of these. We could also use list comprehensions, if you remember those. So if I have, you know, I could use I cubed for I in range 111. That gives me the list version of what we want. And then I can make a NumPy array from a list. So that's fine too. I could have used a for loop. That would be kind of inefficient, but we could do it. And you definitely don't want to hard code it, because if I had asked you to like print out the first 1,000 things, you know, oops, that would be annoying to hard code. You don't want to do that. I don't even like looking at it. Delete it. It's erased from existence. Yeah. Okay. Yeah, what else? Alex.
The smuggle function, I just want to verify that does work on Colab, because it first seemed like that was something that was super useful if we were working in the command line. But
it works on Colab. You have to include these 2 lines.
Perfect.
And that, yeah, so smuggle NumPy as NP. That'll work just fine. We could import a different library just to make sure that, you know, we didn't cheat here. Yeah, now we have the Pandas library.
Cool, but Smuggle will never highlight the same way or get the fun text, right?
Yeah, no, it's a kind of, so you can't actually add keywords to Python. It's
Okay.
kind of a, built-in language. The way this library works is it
Uses
so-
either function that exists already, right?
well, it's kind of tricky. If you so when you execute a function in a notebook, it sends, so this is a web page. And so it takes the web page input and runs it through some parsing process that ultimately sends something to a Python interpreter. What Davos does is it hijacks that process. And if you're going to get like a syntax error because you used Smuggle in a particular way, then instead of causing an error, it does what you want it to do with importing or installing.
Okay.
And then if you try to import something that doesn't exist, then a second set of conditions is handled, and that will install the thing that you're trying to import. But it's kind of a hack as opposed to a true Python keyword, which is why you need these lines at the beginning in order to get it to work. And it won't work in like vanilla Python. So if you had, if you installed the Davos package on your computer and then in a Python script that wasn't a notebook, tried to import Python, this would, cause your program to crash. It wouldn't be compiled properly. It would just, fail.
Gotcha. Cool. Thank you.
Sure.
What is this what is the Smuggle function, or like what is this referring to?
So it's a replacement for import, but it does fancy things. So if I try to import some library that doesn't exist, like HyperTools, then that will fail because HyperTools isn't built into Collaboratory. But if I smuggle HyperTools, then Colab is very happy to call that, but it first checks to see whether HyperTools is installed. It notices that it's not, and then it installs it. And once it does, still thinking here, then you can use it just like you had imported it normally. So, yeah. So it's kind of convenient for this course because you don't have to keep track of like what packages come by default with Colab. I mean, there are hundreds of them. You don't want to memorize them. Well, I don't want to memorize them. If you want, you can, etc. Okay. All right. Yeah.
Can I ask another question, or if you want to move?
Yeah, sure. Maybe let's do one more NumPy question, and then we'll move on to Pandas.
Okay, so my question was, how do you, I guess, like reshape an array that are, so the fifth one says create a 3x4x5 array of random numbers chosen uniformly between 0 and 1. And then it says sort the values in ascending order and reshape the array into a new 20x30 array.
Okay. Sorry, what was the original shape? It was.
I'll put it in the chat.
Okay.
The original shape was 3x4x5.
3x4x5. Great. Okay. So to create a set of floats that are uniformly chosen between 0 and 1, we want to use, we'll call it my favorite variable named X. Just rand is how you do that. And then the way the rand function works, so we could get help on the function to get its syntax. What kind of pops up there, but is it's going to take, okay, D0, D1, all the way to Dn. And this is going to give us the dimensions of the array that we're going to get out. So what that means is if I want a 3 by 4 by 5 thing, then I just pass in the numbers 3, 4, and 5 as my arguments. Okay, so that's going to be a whole thing. And then x.shape is 3, 4, 5, so that worked. And then to sort it, we could just use np.sort. That'll sort everything from smallest to biggest, so ascending order. And then if I want to reshape it, then into a, let's see, 20 by 30 array. Let's see. Well, let me see what the, thought that should work. Oh, maybe, huh, interesting. So maybe you can't call it right from an array. Okay, so np.sort is an array of shape 3, 4, 5. Type things correctly. Okay. np.reshape of this will give you, and then we want the new shape to be 20 by 30. Let's see, why is that not working? Fascinating. Is this the error you were encountering, or?
Yeah, it just was saying like I couldn't reshape it into the size. So I was wondering if maybe I was misunderstanding what it meant by a 20 by 30.
Oh, shoot. Sorry. I see what it is. 20 by 30 is 600. It's not 60. I made a typo. Yeah, it should be, yeah, Frank, you you called it there. Yeah, so probably, yeah, so if I did like 20 by 3, yeah, okay, now that'll work. That makes sense. Yeah, you can't reshape something with 60 numbers in it into a 20 by 30 thing because a 20 by 30 thing has 600 numbers in it. Yeah, orders of magnitude, it turns out, matter. There we go. And then the original syntax that I had tried, let's see if that works. Yeah, that's fine. So actually, these are both ways to do the same thing. And then if you wanted these sorted, then you could just call sort. Or np.sort. Oops. All right.
Sorry, one more question about this question. So my understanding is that we are rearranging the random number in a kind of in a 3D model to a 2D shape.
Mm-hmm. That's right. Yeah, so it's worth also thinking about, you know, you could practice. So you could say, let's see, you have like, you know, 100 things, and then let's try reshaping it. Oops. Into, so 100 things. We actually have to pick something that'll like multiply into 100. So, you know, we can make it 25 by 4. We could make it 10 by 10, etc. And then, when you take your kind of sequence 0 to 100 and reshape it, you can also see like what order are things being drawn from. So we started out with a, one-dimensional vector, and we can see we're filling in the rows one by one, and then you could say like, okay, what happens if you, if you make it 3D? Like, how does it get picked? How do the elements get picked, etc. So, that's a nice way of getting a feel for these functions. Kareem, yes.
So I'm just a bit confused about on line 85, you call NP arrange 100, which means it takes all the values from 0 to 100 or 99 and arrange them in like a 10 to 2 to 5 column. But then on line 65, where you did x equals np.random and you picked 3 digits, or like, I guess that's like the shape of the table, I'm guessing. Is that what the 3, 4, 5
This
is?
one right here? Yeah, that's right.
So then when you go down to the one after the NP arrange 100, you call X, right? So where do you generate the values for inside the array?
That is in this function np.random.rand. So if we dig into that function, then we can see how it works. So it's going to give us random values in a particular shape.
Oh, okay. And so random.rand is the whole function, or is random and rand two different functions that we're calling simultaneously?
That's a great question. So rand is the actual function. Random is a module inside, or it's like a submodule of NumPy that deals with random number generation. And it has a whole bunch of, so rand n gives you like normally distributed random values. Rand int gives you integers, etc. So there's a whole, set of things you can do there. And then if you want to like search for, like, really dig into it, you could say like NumPy random, Google that. And now we'll get the documentation on the like, well, I guess it's hosted on the SciPy Scientific Python website. But it does say numpy.org. So here are all the different things you can do randomly. So you can like get a random number between 0 and 1. You could get a normally distributed random number. You could get a random integer. This is a renamed version of randint. Random sample, if you have a set of things, you can randomly, random sample, I think, is a renamed version of so a few of these are kind of basically redundant with very subtle differences in terms of like the data types you get out. What one was I thinking of though? Choice is useful. If you pass in like an array, you can randomly select elements of that array, which is kind of cool. And then there's like a bytes, you could get random bytes out. You can permute things or shuffle them. There's all sorts of distributions you can draw from if you, if you're familiar with probability distributions, they're useful for, fancy stats stuff. There's a lot of interesting ones built in. And then there's some like convenience functions for controlling the random number generator, which we probably won't use in this course, but yes, Allison, and then Aliza.
A term I keep seeing come up is tuple. What does that mean?
A tuple is
Tuple, sorry.
Yeah, so so if we so a tuple is, you can think of it just like a list, And the way you create it is with rounded parentheses instead of square parentheses. But the difference is that you can't, as far as I know, reassign values, although this allowed you to. Oh, no, I assigned the wrong thing. Let's see if this works. I think it'll give me an error. Yeah. Okay. Yeah, it's like a read-only list. So sometimes that's useful to have. I mean, decreasing functionality, you think of, it's like if tuples do everything lists do except some stuff, you'd think, why would there ever be a situation where you'd use a tuple instead of a list? But in practice, it's sometimes useful to have your like data types or objects not support certain operations, because if a user tries to, or which could be you in the future, tries to do something that you're not expecting, and you like, you know, your program proceeds as if like with overwriting data or whatever, with no warning or error, then you could accidentally, you know, mess up your data set or do something that you weren't expecting. So tuples are like, if you're not expecting the values to change, like, you know, dealing with the sizes of a data set or something like that, or, you know, if you have some like constants that you're storing, you're not expecting to change or overwrite them. And so you can make them a tuple. And then if you try to overwrite them accidentally, I mean, like I did here, it's like, well, if I try to overwrite X, like that's fine, that's perfectly legit. If I try to overwrite Y, which is a tuple, now my program will crash, and you know, that might be useful or informative. All right, so I want to dig into the Pandas library because it's super useful. So Eliza, do you have a quick question or?
Yeah, I just wanted to ask, first of all, if we can call the random function without having to specify the random subpackage.
The what?
The after, so you just explained the inside the NumPy package, the random kind of sub package. So
Yes.
is there a way you can actually not use the random sub package and call the random function?
Oh, sure. Yeah, so you could import from numpy.random import rand if you wanted.
Okay. And then another quick question. Is it possible in a string to change the characters of it directly, or is not possible?
Let's try. Oops. Yeah, no,
Okay.
you can't.
Because it was the same problem as the tuple at this point, that I couldn't change the characters. Okay.
Yeah, so string does not support item assignment.
Okay, thanks. So and
Yeah, these are great questions. In general, just like, you know, it's totally reasonable to ask me all this stuff. I think the way I like, you know, use this in practice, I mean, I've memorized a lot of this stuff because I use it a lot, but I didn't like set out to memorize these things, and you don't have to memorize these rules. Just like if you have a question, you're like, how does this work? Then just try it, see if it works like you're expecting it to, and if not, like what breaks. And that's the best way to learn it. Like I wouldn't try to like take detailed notes on like what are all the rules of NumPy, which is this, you know, 1,000,000-line library, and try to like understand the full thing, because that's just not useful in terms of like advancing your skill set. I mean, it will help you strengthen your memory, but it won't help you do better data science. You can, but what you do instead is like figure out how can you read the documentation, how can you play around with stuff. So if I'm like, how does this work? Then I can look it up quickly. I can like have a vague sense of what the function names are and that sort of thing. I know where to look them up. That's the kind of level of memorization, so to speak, that you need. But I wouldn't try to memorize this stuff, because even if you memorize it for Python and this particular library, like in 10 years when Python is out of style, like the skill set isn't going to transfer. Like things work differently. I mean, when I was in college, we were using like Java and C, and like, you know, things don't work exactly the same in Python. So, and if you use R, like things aren't going to work exactly the same. So I wouldn't try to memorize. I would try to figure out like, okay, what's the basic logic here? How do I like get up to speed with the logic, and, you know, kind of go from there.
So,
Okay.
so just to solve the problem, I would need to convert the string into a list and then change the element of the list. Or is there an easier way?
Yeah, that's a fine thing to do. There are lots of ways to do it. You could take like part of a list. So you could I guess you want it to be 4 to the end. Yeah. Okay. Etc. So you could, you know, take your string, take the first 3 letters, add a Z if that's what you want to replace it with, and then take everything after the 4th position, or everything after this plus this. So 3 plus 1 is 4, everything after that position. Okay, so I want to tell you about pandas, because that'll be useful. Hope we can get through today, we'll see. We will do our best. Okay, so let me paste in a link to these slides so that you can follow along, and there, if you like doing that sort of thing. So for the rest of today, I want to focus on the Pandas library, which is kind of another fundamental package for doing data science in Python. And Pandas is built on top of NumPy. And it stands for Python Data Analysis. So if you remember this like shell sort of, you know, layers looking figure, we've got like Python in the core. NumPy is the first thing we've learned about in this kind of layer. And then Pandas appears like one layer out. So it's built on top of the stuff in the inner layers. Okay. So the main feature that Pandas introduces is it adds 2 new data types to Python called series and data frame. And Pandas also has a bunch of other useful functions for doing kind of data wrangling sorts of things. Pandas is included with Collaboratory by default, but if you're not in Collaboratory, you can use pip to install it using this command. And what I was thinking is, so I want to go through a bunch of examples. So I was thinking it would be useful if you want to open up a Collaboratory notebook of your own and kind of like type stuff in and follow along. You know, you can kind of play around and paste in the commands I'm showing, and you know, see how it goes. Okay. So the first Pandas, the first thing you have to do is at the start of your notebook, import Pandas. And to do that, you run this command, import Pandas, and then let's call it PD. That's the abbreviation I always use. It's just convenient. it's a kind of traditional, I don't know. Okay. So the first pandas data type that I want to cover is the series object. And depending on how you use it, series is like a list or a dictionary or a 1D NumPy array. It's kind of all those things and more maybe. Here's how to make a series, or one way of making a series. You know, kind of similar to how you make a NumPy array. But notice that when you print out a series, it gets printed out as kind of a like table with numbered rows. The reason there is what's actually happening behind the scenes is the data in a series object is actually a NumPy array. And so that's one way that, you know, Pandas is built on top of NumPy. And you can view that array if you type like your data.values. So the values of your data set is a NumPy array. And then the labels of those values is called, it's stored in the index attribute, which you can get by calling data.index. And by default, series objects are indexed by what's called a range index object. And that just, you don't have to memorize that name. You're unlikely to, you know, create one from scratch, but what it's doing functionally is it creates a set of labels that gives each row an integer value ranging from 0 up to the number of rows -1 in increments of 1. If you wanted, you could manually set the index of something to, you know, not be, you know, if you wanted the numbers to count up in some other increment, or you wanted to go to some different range or be offset, you could manually do that by constructing a new range index object. You can use slice notation for series objects, just like you can for NumPy arrays. So here's how you get out the third element, or the second to the third element. One somewhat strange thing, so you can also do things that are a little more sophisticated than just giving, you know, each row a unique integer label. So you can rename the labels for each item. And the way you do that is you can include a new, you know, your set of labels as a list, or a range index object if you wanted, or another like index compatible object. And it just has to be the same length as your data set. Weirdly, so you can, so unlike in NumPy, you can like rename the labels of each item. And you can also use something analogous to indexing and slice notation, even for those arbitrary labels, which can be somewhat weird. So if you want to get like the, you know, data that it corresponds to the label A, then, you know, you can do that. So that's kind of like a dictionary sort of thing. But then if you want the values of the, for labels A through C, you can do that too. And that's kind of like a slice notation for lettered labels, which is kind of weird. Something that's a little strange is when we had integer labels, like if I called data of 0 through 3, no, actually that would work. Never mind. Yeah, so these are inclusive as opposed to, well, here, let me write this out. Okay. Okay, so here's our, oops. Spelling. Gets you every time, gets me every time. Okay. So here's data. Let's see, I'll make another data set without those manually specified labels. Okay. Okay. So if I say x of 0 through 3, it's going to give me row 0, row 1, row 2, and then this implies going 1 before the 3. So it's like the end plus 1. So I don't get out the thing with a label of 3 on it. So that's kind of interesting. If I use slice notation on manually labeled things, then I do get out, like it becomes inclusive, which is kind of strange. A quirk of Pandas. Another strange thing is that index labels don't have to be unique. So if you have like a repeated index, like if multiple elements are labeled with A, then referencing that index will return multiple rows, like all the rows that matched your label. So that's another kind of quirk. The second type of object in Pandas is a data frame. And you can think of data frames as like kind of 2D arrays in NumPy, but with labeled rows and columns. And rows in a data frame are called indices, and columns are just called columns. And then there's a special index data type that stores the row and the columns labels. And somewhat confusingly, both rows, which are indices, and columns, which are columns, are instances of index objects. So index is just like a set of labels from the Pandas framework, Pandas perspective. It doesn't, there's no like new data type that specifically distinguishes row labels from column labels. There are lots of ways to create data frame objects. Moving forward in this course, you're mostly going to find yourself creating data frames by reading in data sets from whatever files store the data. And then you might also find yourself like piecing together data frames from multiple sources. But as a simple example, we could build up a data frame from scratch by using 2 different dictionaries. So I'll just paste these in here. Okay, so we'll have like a data frame storing the area in, I don't know, probably square miles, and population in, I'm guessing numbers of people for these different states. So we've got these 2 dictionaries. And now we can create a data frame containing the population and area for each state by using a dictionary whose keys are dictionaries. And then the keys in that high-level dictionary are going to be the columns of our data frame. And the index is going to be the union of the keys in both of the kind of value dictionaries here. Let's see how it works. Okay. Also notice that let's see. If you, change the order of the keys in these two dictionaries, so areas, let's say you went California, Florida, New York, Texas, Illinois, and then in the other one, you went in the order that's given. Pandas is totally fine with, mismatching order of things. But what it'll do is it'll match up similar keys and know internally that they're associated.
Can it deal with mismatched cases?
Yeah, like if you have some keys that only appear in one.
Like, or if you had an uppercase California and lowercase would it?
I see. It'll treat those as different.
But
Yeah,
we'll still include the two separate in the frame.
Yeah, so let's try that. So we can have two Californias. Yeah, so now it'll just treat them separate. And you can also see what happens if one of your dictionaries here doesn't contain information about lowercase California, the 51st state. It will just put in a placeholder value, which is called not a number man. Yeah. Oh, and you can also get out the indices and the columns. So states.index is a data type of type index that gives you the row labels. And then the columns is an object of type index that gives you the column labels. And then the internally, just like series objects store data in NumPy arrays, data frames also store data as 2D NumPy arrays. And you can read out that array by using states.values. So the values attribute of states. And that gives you access to the array that's kind of hidden underneath. You can pull out one or more column. Yes, Allison.
You may be talking about this later, but are there a way aesthetically to change the colors or the design of the tables, or is it kind of like a standard thing? And also, I don't know if that's important or not. But.
You can do a lot of stuff with how the visual appearance. You can manually edit values using by making this an interactive table that's like a notebook feature. You could filter things, etc. If you want to change how it's printed out, that's just an aesthetic thing that only shows up in the notebook. But there are all kinds of properties. I don't remember off the top of my head. I never change the aesthetics of these tables, but let's see. Oops. Let's see if this. Yeah, I know there are ways of changing particular value, entry, the colors of things or the shading of the cells or things like that based on the values. I personally find it much easier to do that sort of thing using data visualization libraries specifically. So if I want to print out the values of some table and color the fonts or the cells based on the values, then I'll use a package specifically, made to do that. But you can do it. I'm pretty sure that Pandas supports full HTML and CSS styling. So, like a web page. So you can, dig into that if you wanted. But in practice, the defaults are pretty nice just for printing out the values.
And I assume we'll learn the other aesthetic stuff later. So
yeah, yeah, that's right. Yeah, Elisa.
do the inputs of the data frame function need to be dictionaries? Or
No, there are a gazillion ways to make data frames. Yeah, let's see it. Let's see if we can pull up the Pandas website. So you can see all the, oh, I could have just printed this out within the notebook, but whatever. Here's another way to get documentation. You can create data using any, it's called like Python iterable. So like a list-like thing, a dictionary, or even a data frame can create a data frame. The dictionary itself, with that tells you what the different columns are, can itself contain like series, arrays, constants, any list-like thing. It's quite flexible. And then the other like place to easily create data frames is by like reading in an existing data set, like a spreadsheet or a website or something like that. And there are tons of functions for parsing existing data sets, and what you get out at the end is a data frame. So that's the kind of most common thing that we'll do in this course. Let's see, we just have a couple minutes, so maybe I'll talk about indexing, like getting stuff out, and then we'll get through the rest of this presentation on Monday. So these are worth playing around with. I'll go through them quickly in the interest of time, but to get out a column of the data set, you use square brackets and then the column name. You can also pass in a list of column names, and that'll give you, a list of columns. So if you just get one column out, what gets returned is a series object corresponding to that column, where the index of that series is whatever the index of the data frame is. So it's like the row labels of your data frame. And if you, instead of just a single column, if you pass in a list of column names, you'll get out a new data frame object that has the same rows, but just the given columns. To index, so square brackets correspond to columns. To get out, let's see, what was I trying to say here? Oh, yes. So like states of area, say, that'll get me, a data frame with, or sorry, a series object with just that column. But if I want to get out a particular row, I can't use square brackets anymore. And the reason is because there's no column with the name California. So Pandas needs a way to determine whether you're referring to columns or rows. To get out a row, you use .loc and then California. That returns a series object that corresponds to the given row. You can also index a data frame with the like numbered indexing. So to get the first inclusive through third exclusive columns, or sorry, rows of a data frame, you can use iloc for indexed location. And that will give you back a data frame whose rows are indexed by the first and second, or indices 1 and 2 of your original data frame, and the columns are going to be the original column, so you get back a data frame, etc. You can also add columns to a data frame object using square bracket notation, just like for a dictionary. So if you wanted to compute the population density which is the number of people divided by the area, then you can use this syntax here. You can also, if someone new is born, you can adjust the value in your data frame by using .loc, and then the row and column, and then set its value to whatever you want the new value to be. Okay, so on Monday, let's play around with an actual data set. And also on Monday, I want to hopefully get to some data visualization tools. And then after that, I guess it'll be on Wednesday, we will get back into data storytelling mode and start playing around with some data. And for assignment 4, which is your kind of first real data-driven story that you'll do the analysis for, we're going to be looking at some data from the Vermont Department of Health. They've shared with us some data that they want to get insights into to help understand what's happening in our area. And on Friday next week, we'll have a special guest speaker. So the person who runs the Vermont Department of Health and also an epidemiologist from the Department of Health will come chat with us and tell us about what their data is like and what questions they're interested in. And then we'll actually try to answer some of those questions by digging into the data that they send us, which will be real data from the local area. Just one of the questions I had chatted about with them is the Upper Valley is kind of a natural experiment because we've got kind of the Norwich area and Hanover area, are very similar geographically, same weather, same natural resources, et cetera. But the governments of Vermont and New Hampshire are very different. And so it's an interesting natural experiment from an epidemiology standpoint, to compare health outcomes and that sort of thing across those two regions. So that was one of the sorts of questions that they're potentially interested, but they'll, I'm sure, tell us more about what specific things they want to get into. Yes, Allison.
So does that mean that we're basically only gonna be able to start on assignment 4 over the weekend if it's due that Monday?
Oh, we'll figure out when the assignment will be due. I'm guessing that we'll extend the deadline of that assignment.
Okay.
Yeah. I wasn't sure how long it would take us to get through NumPy and Pandas, but it's taken, I guess it'll take an extra day. So that's totally fine. Also, the Department of Health folks, the best day for them was Friday. So, that's okay.
So do you think it would likely then be due on that Wednesday, so the 16th?
I'm guessing what'll happen is we'll do our brainstorming on Friday with the Department of Health folks. So a week from today. And then I guess we'll see how we're feeling after that class to see if we want to have an additional brainstorming session just as a class. And then we'll take maybe part of the following Monday, and I'm guessing Wednesday to debug everyone's notebooks and that sort of thing. So, make sure people can load in the data correctly and whatnot. And then whenever everyone's feeling sufficiently debugged, the next class will be when we actually do the data stories. So I'm guessing they'll be due a week from next Friday, so 2 weeks from today.
So the 18th probably?
Yeah.
So that's Friday the 18th. Okay, great.
Friday.
Yeah, because also this weekend's Winter Carnival, so that's good to hear. We'll have more than just the weekend to do it.
Yeah, you don't have to skip Winter Carnival. You can, you can if you want. You don't have to. Cool. All right. And All right, well, I will, and sadly, next week will also be remote. But the numbers are going down, so we'll see how it goes. If the numbers go way down faster than they have been, maybe we'll transition to in-person sooner than the end of next week, but we'll see how things go. Well, I guess on Friday, we'll be meeting remotely with the Department of Health people anyway, so Friday will be remote anyway. But I'll see you at least on Monday, probably on Wednesday over Zoom. Elisa, did you have a question?
Yes, is there a way I can ask you a question on the second assignment, the third assignment one that we submitted yesterday?
Yeah, sure. Yep, and also if anyone else is having trouble submitting assignment 3 or has questions on it, you can ask on Slack, or I can stay for at least a couple minutes after class. For the rest of you, have a wonderful weekend, and I will see you next week.
Have a nice weekend. Thank you.
So is there anything we should